زملاء الكرام، السلام عليكم ورحمة الله وبركاته. بنرحب فيكم بلقائنا ال17 مع شركة بيكو وبمثله المهندس نيراج سالفراج. محاضرتنا اليوم أو لقائنا اليوم 2 كيس ستادي بيحكي فيهم المهندس نيراج عن حالتين بمبنيين بكندا لاستخدامات الدلتا بيم وحلول البنش في البلاطات. المهندس نيراج من الدنمارك، معه جنسية دنماركية من جامعات الدنمارك، يعمل مع شركة بيكو منذ 13 عام قضاها بالدنمارك، آخر 3 سنوات عمل بالخليج العربي بالإمارات والسعودية وعمان. Dear colleague, let me first welcome Mr. Niraj, who's representing Biko company. Today webinar, he will introduce to us or present to us 2 case study regarding bunch slab and delta beam solution. Also, let me thank Mr. Niraj because actually he was busy, and after scheduling this webinar, some emergency come by the way, as we said, but he insists to not apologize and give this webinar to us. Welcome, Mr. Niraj, and I hope you will share your screen.
Yes. If you allow me to share the screen.
Yes, immediately.
Yes, thank you.
Thank you.
First of all, engineer, thank you for the nice introduction, and welcome from my end for today's webinar on tall building solutions. As mentioned, my name is Nurajuddin, but shortly called Nick as well. If you find that more convenient for you, you are most welcome to call me Nick. As introduced, I have been working at Payco for almost 13 years, and the last 3 years has been in UAE with various projects from KSA to UAE itself and Oman and India as well. Before I will start, I would like to, on behalf of Payco, thank everyone from Engineerstalk to spare your time with us. And of course, special thanks to Engineer Abdul Hakim to give us the opportunity to make this event take place. The aim of today's presentation is to share with you how Payco solution for tall building can enhance the efficiency of the building method and operation during the construction. I will not only take you through the 2 project which was presented today. Moreover, I will walk through how Payco solution can be applied from foundation to top of the building. A few practical things. Presentation is scheduled for 1 hour approximately, with 10 to 15 minutes Q&A on the end of the presentation. In the chat, I have shared with you the white paper on the tall building solution. There you can find much more information on the projects which I will go through today with you. The content of today's webinar will be a short introduction of the company itself. This is the 2nd time Payco is holding it, so for the newcomers, a few slides on Payco, who we are, what we're doing, and where we are operating from. Then we will go into a definition of tall building, and then very brief on the design aspect, without deviling on all the parameters, but just a very brief. And we will also move to the structural system to help resist the lateral forces. And of course, the main part of today's webinar is the Payco solution, which application can enhance the different characteristics of the tall building challenges. So Let me go here. Yes, the PECO has been existing for more than 60 years. Actually, it was founded in a small city called Lahti in Finland, and has been run by the same family. The second and third generation has been taking the company into the new era. Uh, all the applications will be provided today in the presentation are in-house manufactured. We believe independent is the key word, because many of the things are key component in all kind of buildings, not on tall buildings. And what makes us different from other players is that we reinvest a lot of our the earned money onto R&D, because innovation is what keeps the company running and ensure that we are meeting the customers' needs wherever we are operating. Basically, we have four main business categories related to product segment is precast connection, which I will go through today as well with a few project cases. Then we have cast in situ application. Here, the product we will go through is Armata. Basically, it's a punching reinforcement to prevent the punching failure. And then delta beam frame, which is enhanced the slim floor structure. And then we have also wind application for onshore foundation. This we will not go through today. But all four business segments, we are doing our utmost to be the forerunner. It means we are doing a lot of tests, not only in-house, but with the cooperation with multiple universities around the globe. Since we are the European company, the most of the collaboration is done with the university located in the European continent. Just to show you where we are operating in the global map, as you can see, we have manufacturing Drasselheimer, where we are serving the GCC country, basically the old MENA region, along with the Indian market. Otherwise, we have manufacturing facility in 11 different locations, from China to US to Australia. And then we have local legal entities. So basically, these are sales and technical team located in 33 countries around the globe. So let's go to the definition of the tall building. See, you can call it high-rise building, tall building, or multi-story building. Basically, they cover the same name. The Council on the Tall Building and Urban Habitat mentioned that a high related to the context, proportion, and tall buildings embracing technology as the criteria, which can determine whether the building can be classified as a tall building. If a building can be considered as a subjectively relevant to one or more of the above categories, which I just mentioned, then it can be considered as a tall building. Although number of floor is actually a very poor indicator of defining the tall building due to the changing floor to floor between different buildings, for example, in offices or versus residential. But a thumb rule is that a building of 14 floors or more than 50 meters in height could typically be used as a threshold for a tall building. Since PECO is a member of the Council on Tall Building and Urban Habitat, we simply accept the definition given by them. If we move to the main design aspect, once the building grows taller, the vertical load increases with the height at the same time the horizontal loads increase significantly. And obviously this affects the tall building much more. Therefore, tall building must have adequate bending and shear resistance and shall not lose its vertical load bearing capacity. So in worldwide, tall design practices are different and might be covered by a combination of gravitational, wind and seismic, depending on, of course, the local building code. The main design objects are to ensure adequate lateral stiffness of the building. In principle, the structural engineer need to satisfy two.
हाँ जी, हाँ एक मिनट मैं इसको पीछे से जी क्या हाल है?
They have to satisfy two serviceability criteria. One is lateral deformation, and the second is motion perception. Satisfying the first means limiting the maximum lateral displacement, as you can see in this picture here, top of the building and inter-story drifts separately. The main purpose here is to controlling the deflection of the non-structural element to function properly. The practical way to limit the drift is to increase the bending stiffness of the horizontal member, or adding a shear wall, or even designing the stiffer connection. Second criteria is to ensure occupants' comfort level, which is dictated by the amount of wind-induced movement. And in fact, a tall building can be allowed to sway considerably, but the acceleration rate at which movement increase must be damped with acceptable limits. Those limits are based on sensitivity of our inner ear to motion. Acceleration can be damped on different ways, either by stiffer structure or sometimes by supplementary mass damping, such as a tool mass damper. It will simply limit the horizontal acceleration with a mechanical shifting large mass in the opposite direction of the applied lateral force. And here in the slide on the left side, sorry, the right side, you can see the largest and the heaviest mass tune damper on the world-known famous Tapai 101 in Taiwan. It was once the tallest building before Burj Khalifa took over. If we go to the classification of the typical structural system used in tall building, as discussed before, transferring the gravity loads and the important role of the structural system is to resist the lateral forces. Therefore, the hierarchy of the system is to mostly categorize with respect to the relatively effectiveness in resisting the lateral force. So what does it mean? As you can see here in the picture, what engineers have tried to develop is some kind of system based on exterior structures. Basically, all your columns will be carrying the lateral forces, or you will have interior structure where you have cores or shear walls to take the stability of the lateral force. As you can see, this is done by Mr. Mir M. Ali and Koshung, if I pronounce it correctly, Sun Moon. And this is basically categorizing or classifying based on these two criteria. Because of the time limit, I will not go through all these systems separately, but make it much more simpler. One of the first structural system which other systems start to evolve was this rigidly joined structural frame. The core idea was here to place as much vertical load carrying element as possible on the periphery of the building to maximize its ability to reach angular acceleration. As seen in the middle picture, you can see the two system and the strength and weakness. So when you have rigid frame system, it has a high deflection or low stiffness. And meanwhile, when you have shear wall system, it gives you low deflection and high stiffness. To overcome the shortcoming of a single structure system, a natural idea is to integrate the strength of different systems to obtain the desired behavior of the tall building. With reference to the classification of structural system on the previous slide, rigid frames are economically for building roughly up to 25 to 30 floors, above which their drift resistance is costly to control. So, however, a rigid frame combined with shear wall, the resulting structure becomes much stiffer, and you can actually go up to 60 to 70 floors. To reach to the super tall buildings or towers, the mentioned system is not sufficient. You need much more complex system to obtain your stability. And a super tall building are classified when you have a height of 300 plus. And for those tall building, you need mega tubes or super frames with outrigger system. So let's move to the main part of today's presentation, and this is where Paiku's presence in the tall building. See, regardless of the structural system chosen by the structural engineer, the connection between the elements are vital in every tall building. One of the most important aspect of the lateral force design is the connection between element of this building. See, over the years, PICO has developed multiple solutions to simplify the design and installation of connection for tying structural elements together. And in this schematic diagram shown on the left side, you can see the core as a major lateral load transferring system on the whole building. And I would say it appears in the whole building to form a spine for the vertical transportation and service. The core generally act as a vertical cantilever, taking both vertical and lateral loading. The rigid frame on the parameter, as you can see here, contribute to lateral load transfer from outer column to the core through the floor diaphragm, and improves the lateral stability of the overall building. The link between these, I would say, fundamental element of the tall building can be then made with the PICO connection, and this is what you see on the right side. On the coming slide, I will take you through some of the PICO solution with a real project case study. I would like to start in the foundation and what kind of solution we are providing. In this case, I have only taken one project with you. We have multiple reference projects in our portfolio, but since I want to showcase you many cases as possible, I have only taken one project. In this project, PICO's double-headed shear rail system is not tying the structural element together, but contributing to the element in geometry and the construction process, which I will also come into in the later slide. So depending on the market requirement, compliance with the local design standard or material standard, you will find two types of punching reinforcement in PICO portfolio. One is called PSP punching. You will see in some other presentation. And then we have Armata punching. The difference is basically Armata is used as according to ACI, and the PSP is used in relation to Eurocode in the European market. So we have a system which covers the European code system and the American code system. The same solution works for foundation, beams and a wall as well for the punching. This Monde condominium in Toronto in Canada is a high-rise project and in particularly using the shear rail system in the foundation wall of 5-level underground parking. Because this, as you can see in the picture, the site is located directly adjacent to lake. The walls are designed on the assumption of a water table being at the ground surface. So a 5-story underground structure, this pressure creates a high shear forces on the both sides of each suspended slab. Easy to install stud rail were simplified and designed to resist these shear forces. Traditionally, what you will do, you will have rebar stirrups, which will be used to strengthen the foundation walls against shear force. But first of all, they are very labor intensive. And compared to working with the rebar stirrups, shear rails gradually reduce on-site manual labor. Installation is simply done with the 2 workers, as you can see in the picture on the right bottom corner. One guy will simply place the stud rail, and the second person will tie the stud to the rebar. See, this solution is not only enabling cost-effective construction process, but also improves the design itself. So comparing to working with a thickened foundation wall, the shear rail makes your wall thinner and increase your interior space for parking. Just a sample of the construction process itself, installation phase was around 80 rails per hour with only 2 workers. So if we take an average of 10 studs per rail, this is actually equivalent to placing and fixing 800 stirrups in 1 hour with only 2 workers. I believe these numbers significantly showcase the improvement by using the punching reinforcement system. Let's go raise to the top of the building. Here I will explain to you about floor-to-floor height solution, basically slim floor. We have multiple applications to achieve this this target. But some of the added values having the slim floor is that, first of all, you can add extra floors, or you can reduce the overall height. And for the developer or the end user or the client, it simply means better return of investment. And this is something was the key factor for the some of the project I will showcase you. As mentioned, it's not secret that developers want to maximize the number of the floor in order to get more rentable space within a certain height allowance. And the slim floor structures actually helps very well. By reducing the floor plate thickness, floor to floor height becomes lower, which in turn yields more floor for given building height. And this project, 300 Main, is a 42-story building on the corner of Main Street and Graham Avenue in Winnipeg, Canada, and is used the slim floor concept. A typical floor in this project is a combination of delta beam and hollow core, and you can see steel columns as you see in the left bottom picture. The other option of using hollow core with the wide flange steel beams was also considered for the new tower. But this solution would have resulted in a building at least 15 meters or 50 feet taller, which would have increased the total price of the project significantly. So it was clearly a no-go on this project. And delta beam instead have saved overall height of the building to additional floors, and they maximize the total square footage. Talking about the savings in the same projects, I will go to the foundation size because there's a few examples how this has been achieved in this project. The powerful argument in favor of slim floors is because you are reducing the weight of the overall structure, and which turns makes the foundation less expensive. In this case, 300 Main new tower is designed with the same foundation pad with a similar building called 360 Main, which is closed by this new tower, was built in 1979. Since the combination of delta beam, hollow core, and steel column is much lighter, the previous done tower 360 Main cast in situ clay structure, the developer was able to increase the number of floors by 30 to 42, and using the same foundation pad as this cast in situ structure. So this is another strong argument why generally slim floor structure are very much recommendable. And the added advantage of delta beam, composite beam, is the 2 hours fire rating without any additional fireproofing, which is also proved to be substantial saving compared to the conventional wide flange steel. The next project is also located in Winnipeg, Canada. Like the previous project, is also delta beam composite beams, and it played a very important role in meeting the needs of the architect and the structural designer. The architect of the greenhouse project in Winnipeg, they were looking for a solution that would incorporate a slab thickness of only 9 to 10 inches. In centimeters or millimeters, it would be around 230 to 250 millimeter. Again, the delta beam system was the perfect solution, allowing the top and bottom plane to include both the structural floor and the structural beam in only 9-inch deep system, without the beams projecting below the slab. And you can clearly see in the picture here, they are able to have floor-to-floor windows without any protection. By using the delta beam system, they reduced the floor inches by 16 inches, and this translates into 2 extra floors compared to the conventional structural system technology. Besides adding your extra floors, since everything is prefab, it also allows you for rapid speed of erection, since everything is prefabricated. Delta beam composite beams were then connected with the column using the Pico modular PC cobble, and I think you can see it here barely. It's actually a hidden cobble system, which is welded from the factory on the steel columns. So it gives you this kind of liquid-like ease of installation. And flat ceilings, as you saw in the previous slide, also means straightforward HVAC installation that further reduce your building time. And an additional bonus to the glass house building site was the delta beam composite beam did not require any of these kind of into cement coating. Into cement coating is a standard industry procedure. If you have steel, is export, but this has to be done on site, and it takes time. You need a primer, a base coat, and top coat. And none of this was needed with delta beam, as the beam is cast in concrete. To prove this point, delta beam actually UL tested and has achieved 2 hours, 3 hours, and 4 hours rating without no additional fire protection of the exposed steel part of the delta beam. The next project in the slim floor is not with the delta beam, it's with our PSP and Kobo. Now we are moved to the European continent. Now we will not have Armata as mentioned earlier. We will speak about PSP, basically the same product, but due to the local requirement, we are calling it PSP. See, reinforced concrete slabs has been used in this project, supported by high-strength precast concrete column and shear wall cores. Generally, in situ flat slabs are characterized by absence of the beams. Whatever loads are added onto the slab are transferred directly to the column. So the columns need to punch upward through the slab. So to avoid drop panels over the column position in the slab and to accommodate the high shear stresses, Pico PSP punching reinforcement with combination with Kubu column caps was applied for this project, and you will see that in the next slide as well. So Kubu is basically additional reinforcement to take high shear force along with our PSB. And this is the Kubu, the steel part, which is placed on top of the column. And the thickness of the slab was actually kept on a very relative low level with the help of our product. Part of the concrete and column were produced in precast element factory and delivered with our Kobo, as you can see on the right side of the picture. The installation chosen in the Eurocode, you have different classification based on your demand of the project. The highest execution class is class 3, and our Pico factories in Europe are classified and can do this kind of welding, which is required in execution class 3. So again, it was a very good choice to have Pico as a player here due to the compliance of the code system. The next project is a post-tension flat slab. And in this project, it was used in every floor of the lighthouse tower project in Aarhus, Denmark. And post-tension in this project actually helped to achieve a formation of 200 milli slab thickness, with up to 8.2 meters span without any column. So the slabs are supported by central core and the blade columns on the perimeter of the building, as you can see in the typical layout. In addition to the outrigger action, where the slab is rotationally fixed to the column and the core, was employed to increase the stiffness of the building against wind, loads, and vibration. So these requirements actually made the column slab connection design very critical, and the high load on the connection required use of punching reinforcement for all floors. And again, Pico was chosen as a supplier and as a design partner. And this is simply due to the Pico PSP punching reinforcement has a higher upper limit for punching capacity. And this is what I tried to put in the slide here. We are able to achieve 30% higher resistance compared to traditional shear links. And this is simply due to the header stud formation you have on our product. And it gives you a much higher anchoring effect in the concrete. The project is ongoing and then planned to be executed or completed in 2022. And it will be one of the highest buildings in Denmark. The last project which I will take you through, this is a Alsik hotel, also located in Denmark in the southern part, city called Sønderborg, and it's designed by the world-known architect called Henning Larsen, who also designed the Ministry of Foreign Affairs in Riyadh. And this is the picture you can see, just a bonus information for you guys. The concept, the structural concept is very much in line with what we spoke already. You have a central core in the middle, which is cast in situ, and then you have in the perimeter precast columns with the delta beam, with the green, and then internal beams, as you can see here, the small beams in the corridor area. So the MEP can be done without any drop beams. And then supported by, you have a precast wall, shear walls here. And this is how the structural system has been done. So in the next slide, you will see the detail. So delta beam is running through the columns, and then we have also utilized the Pico column shoe into this connection, which I will come into later in my presentation. And then one of the main challenges was to control the deflection in the delta beam. They were having these glass facade, and those glass facade are directly fixed to the delta beam. And due to the sensitivity on the deflection on the facade, the supplier had a very high demand on the deflection criteria. So all the beams on the periphery here are designed for L/2000 for the incremental deflection, which is applied by the movable dead load and live load. So we can design the beam for a very tough deflection requirement as well, and still achieve a relatively slim floor structure. Let's move to the main part of structure in the tall building. That's the core. During the construction, the concept is the engineer's concept is to keep the core without any protruding elements, because this will simply enable you to have this kind of climbing formwork, as you can see in this small animation. And I will go through with you some application which can enhance or meet this requirement without having any protrusion or any bended bars bending out and having all this wet connection, which can be very hard to control. And the quality assurance. The first one was designed with the closely spaced precast concrete columns, along with cast in situ shear wall core in the center. The space between the core and the perimeters was bridged by prefabricated concrete beams with a filigree plank grounded with in situ concrete. And this, as you can see here, all the colored lines are prefabricated precast beam, and then they are connected with, as you can see in the picture, with the core and the precast column. The next slide, you will see here the cast in situ reinforced concrete shear wall, and the cores are widely spread in the tall building, as mentioned. And this is simply due to the in situ concrete technology is favored by many engineers, and this is simply due to the structural continuity it provides of the element. But on the other hand, what we are seeing is that a clear increase in use of precast concrete technology in tall building. And what makes precast a worthy choice is that the main advantage is the high speed of construction, reduced shoring requirement, and easy quality assurance process to be implemented at the site. And the major challenge in this project was limited space available on the building site. The storage capacity in the upper floors of the tall building was very limited. So prefab casted concrete columns, beams, and slab were selected to the project simply to eliminate the need of space consuming formwork. To simplify the construction, you can see in the picture our PSV cable has been embedded into the shear wall before the reinforcement cage has been applied. And once you remove the mold from your core, what you will see a clear surface, and then you will fix the steel part afterward, which is colored with the red. And into the concrete beam, you have our beam shoe, which is embedded into the precast plant. So it's again a legalized installation process. There's a recess in the bottom, and you will simply slide it onto the cobble. Based on the loading requirement, we have different colors. It just show you that different colors has a different capacity. The biggest cobble we can design can take approximately 1,500 kilonewton. So in this section, I would like to introduce how to connect structural element in a simple way. Some of the item I will go through is basically plywood boarded connection. And here we will moreover look into the single element itself. And the first project I will take you through is again in Germany, Frankfurt. A central feature of the architectural concept here is the hip swing, as you can see here. And alternative cantilevering of the 15 to 22nd floor, and basically residential floors. You have a the direction is changing up to, with a cantilever, up to 5 meters. At that level, the building forms a spiral by shifting the stories along its vertical axis. Above the 22nd floor, the tower returned into to optimize floor areas and complete its rotation and realign with the structure underlying beneath these alternative cantilevers. Additionally, the first 3 base level, as you can see here, designed as a public space, are also offset along the vertical axis, which means that the geometry of the supported section had to be optimized in order to minimize the inclination and deflection of the columns. The office floor from 3rd to 15 and from 23 to the roof, the building have the same regular floor plates. For these typical floor, the diaphragm consists of main beams, as you can see in the typical floor in the center of the slide. So again, you have a core, you have the outer perimeter is supported by precast column and precast primary beam, and then it's connected by secondary precast beam. So there are a lot of connection which has to be considered. As you can see, the beams are also acting on the secondary beam are acting on the primary beam is also generating torsional moment. So to avoid that torsional moment in the beams, Pico column shoes, and this you can see here in the right upper corner, Pico HPKM column shoes and the Cobra anchoring coupler were used on all levels from second floor. And this solution transfer the tension forces through the joint of cast in situ structure in a quasi-modulistic behavior and allow for fast assembly of the precast construction. In addition, the column shoes, which is embedded here, meet all the requirements, including 2 hours fire resistant for the load-bearing structure. The next project, we will fly back to Copenhagen in Denmark. Again, in this building complex consists with the 2 towers and 3 small wings, which were situated around a central atrium. This 22-story high north tower is especially for its curved facade columns, as you can see in the picture. Since crane time was decisive when building this tower, it was decided to use 2-story precast concrete column in the facade. And the 2-story facade column, as well all other precast concrete columns, were done with Pico's HPKM column shoe. And here you see on the top of the column the anchor bolts, which are embedded on the concrete column. And here you see on the bottom part of the column the Pico column shoes embedded. So it's a 4-ball nut tied together, and once the ball and nut are tightened, you will have a fully rigid system. And as you can see in the picture, no bracing is required. So this was again one of the reasons why we were chosen as a design partner and supplier of the system. And the last project I would like to highlight very briefly, again, when you have this kind of knife column sections, here is done, and those are also designed to take moment in both directions. And this is situated in Manchester, UK. If I will go to the next, so design flexibility. So in this section, I will just showcase you one project where normally PEICO, we are engaging as a design partner when the project is being, let's say, not from the concept stage, but we are coming and providing the stiffness value to ensure that the global stability is secure. So we are not doing the design itself for the full structure. That is responsibility of the main lead consultant. But there has been cases where PEICO has taken the full scope of design. And the next slides, I will go through one of the projects. And this is actually a 20-story tall building. It's called Icon, located in Sweden. The key features here, as you can see in the right, sorry, left top corner, is the massive cantilever, which is the crown of the building. The global stability of the building was achieved with a braced delta beam frame, a steel and concrete composite structure consisting of composite columns, delta beam composite beams. The composite frame was paired with a hollow core slab and then precast elevator shaft. So no cast in situ element at all, no cast in situ core whatsoever. With the delta beam frame, of course, you can, as mentioned previously, you can maximize the space utilization, making the room and for more people with the same available space. And beside the slim floor that allows for height to floor to ceiling height, the slender composite columns takes up very little space as well. And then this translates into more floor area to sell or to rent. If I will go to the next slide here. In this structural system of delta beam frame is based on nominal pin joint between beams and column. While the sway stiffness of the frame is arranged by diagonal braces, as you can see in the picture here. In the brace structure like this, most of the beams and columns were designed on the vertical load only, assuming the braced base carry all the lateral loads. So the lift shaft, which was precast, and due to the very low axial load, was not even considered to take any lateral load resisting contribution. And then, as mentioned previously, the unique feature of the building is this 3-story crown structure on the top of the building, and with up to 14 meters cantilever from the building footprint. And this was done by mainly cantilever trusses and bolted together at the site. I am coming to the end of the presentation, so just a quick recap. I will not go through one by one, just to show you that we are able to provide you solutions from the base throughout every single floor to you reach the top of the building. So the base we have is what we call Armata or TSB. It can be used on foundation, wall, or the slab. And then we have different applications to reach your target if you are looking for slim floor structure, either with the delta beam or with our punching reinforcement. And if you want to combine precast element with cast in situ structure, as showcased you in this very complex building, we are having connection details to accommodate that as well. Before we will go to question and answer time, I would like to showcase you 3 different videos, which is showing the project in real action. So the first project is also located in Copenhagen. It's a G+30, if I remember correct, and you have a core in the middle, and the rest of them elements are precast. So here you will see the bolted connection in action. So let's go to the next one. It's not a high rise, but it showcases you the delta beam frame system and its ability to enhance the construction time and how it's done in a practical way. And here it's since it's not a high rise building, we were able to do it with the pit connection system, which you will see in the video as well. But here is consists of composite columns and delta beam composite beams along with the hollow core precast slabs.
Are you looking for a building frame that saves both time and effort? This is it, the Delta Beam frame. A complete one-supplier solution consisting of Delta Beam composite beams, composite columns, and other additional steel structures of the frame. Being a slim floor structure, it allows for a maximized room height and up to a 12 by 16 meter grid. Additionally, Delta Beam frame enables architecturally demanding facades and shapes and flexible open spaces. Our expertise in modern 3D design tools help us to find the optimal solution together with your architects and structural designers. The CE Mark frame components are manufactured in our state-of-the-art factories. Components are easy to transport, store, and install. First, erect composite columns with our bolted connections. Next, hoist and install the delta beams. Now you're ready to install the slabs, whatever your chosen system is. Fill the composite columns with concrete and cast the delta beams while you concrete the slabs. Note that you don't need any extra fireproofing. Delta Beam frame has structural fireproofing built in. Additionally, you can create complex facade and interior shapes with formwork integrated in the delta beams. Easily install safety rails. Use Petra slab hangers to create openings in the slabs. Install the wall elements fast and easy with Sumo wall shoes. A single frame supplier for saving time and effort, the Delta Beam frame is easy to erect piece by piece. For you, it means an easy-to-manage project. For more information, take a look at payco.com/deltabeamframe and choose the faster, safer, and more efficient way to build frames.
At the last video, it's not a real project presentation, it's actually animation on our Armata. What I can say is that we have done multiple projects in KSA with this Armata for large project where there has been substantial saving for the contractors and of course achieving your slim floor so your MEP can run through without any bendings. So let's have a look at this Armata and then we will go to the question scenario. So again, just to give you small information while the video is running. So the idea is to avoid all this kind of broad methodology you are using to accommodate the punching focus. As mentioned earlier, this double-headed stud or Armata is called due to the anchoring head started head on the product simply give you a higher anchoring capacity. This allows you to reduce the slab or you simply remove the top panel. So the installation here can be done in two ways. One is that we create the mesh that we show the dimension, the bottom and top mesh, and based on our design, either we will design for you or there is a pre-design tool in our webpage. It will then, based on the given information, it will the length and spacing and so on, you just place it on the top. The second method is to install the stud, and then you will create your mesh around it, and it will give you the statement to have the required concrete cover or the stud. The upper limit here is of course the maximum resistance of the slab itself, so we can't exceed that. So that was pretty much I would like to showcase you. As you can see here, you have my email and contact information. You are more than welcome to reach out to me in case of any project inquiry, or you can simply visit our homepage, our global homepage, FICO.com, or our local golf homepage, FICO.ae. And the next, which I would like to highlight, if you want to find more project where you see our application has applied, you can go to FICO.ae reference, and here you can find all types of project FICO has been involved, from delta beam to Armata to this bolted connection, and you can filter based on location and country, or you can filter according to the building type and product as well. So let's move to Q&A. I hope I covered the most of it today. At least I was covering your.
Thank you very much, Mr. Niraj.
Welcome.
Just let me see if there is any question, so we can take. And today, I believe we will change the habit for the question, and we will let every or each engineer or every colleague, he will ask by himself.
Okay.
So if you please, by raise hand, we can do this. I have one question, Mr. Niraj. How
Yes.
actually, how the connection will work between the column and the beam from a structural design point of view?
Are you talking about concrete beam or delta beam?
The delta beam, definitely. We will not talk about the concrete. Concrete, it is this is something else. But now, delta beam with with precast, or delta beam with cast in situ column.
Yes.
How
So,
the interaction will be between them? With the steel, we know that. With concrete, we know that. But now with the steel, your product with the concrete.
yes. So
This question maybe will be followed with some other question related to the same question. Please, if you can, if you need, I will ask all, or you will answer one by one.
No, I will. If you can manage the question for me, then I will try to do my best to reply. As mentioned in the initial in my presentation, I just sharing my screen with you.
Okay.
So as you can see here, the delta beam here, if we are using it in this kind of concept that you have the core and then you have the perimeter to take the lateral forces, the delta beam in this case will only act as a gravity member. So the connection between columns and beams will be primarily as a pin connection. But the delta beam, of course, along with your flow diaphragm, will able to transfer the axial forces into your core, which is induced by the wind or seismic.
طيب, the question is the same point for the earthquake effect on this connection, and still we are doing some preparation for this connection to dissipate the earthquake effects. So what we are doing here?
So what Payco is doing here, yes. So basically,
because as you know, we are going to high-rise building, 40 floors and 30 floors, and there is effect for the earthquake or wind.
yeah, so as you can see in this building, which I was going through with you, these are simply pin connection. There is this kind of, I will try to take this picture, the same similar here. So you have a steel column with a hidden cable, and here is simply pin connection.
Yes.
What we are doing though in Payco at the moment, we are testing the beam on the ductility behavior. The connection itself, we are studying a lot. If the beam is part of the moment resisting system, then the connection is becoming a very vital part of it. And these studies are ongoing. What we are doing when we are having cast in situ columns, actually the beam, in most of the cases, we can design the beam as a continuous system. Basically, the beam will run over the column. And in those cases, all the rebar which is coming through your below column will penetrate my beams. It means simply that I will make opening in the bottom plate and the top plate, so the rebar can go through. To address the shear flow between the beam and the column, what we have proposed in some project is to have a shear stud, which is this is difficult to show here, but what we have done in the steel plate, you will weigh the shear stud, which is embedded into the concrete column, and then you also have shear stud, which is coming into the beam section itself. So it allows you to transfer the shear flow between the element. So we will not utilize your rebar to take the shear flow, but those will be taken by the header stud, which is applied separately.
Okay. The other question, is there any test were conducted for earthquake effect?
Yes, as mentioned to you, we are doing a lot of ductility tests, and I can show you, I can send you later on the first part of the test we have done. And this is done with the collaboration with the university located in Athens, in Greece. And Greece is a high seismic zone in Europe. In that area, we have done the first phase of the ductility behavior of the beam. Basically, why we call it ductility and not seismic test, because ductility is the most important part, that the beam itself can have a lot of capacity without failure. Of course, you can allow considerable deflection, but without any failure in the critical element. So these tests are ongoing, and we can share what we do in Payco once we have preliminary conclusion on the test we are done. We are releasing what we call white papers, and these white papers are basically not concluding anything but showcasing the result, because conclusion need to be done based on several tests, and this is ongoing, and this is a program which will take a couple of years to conclude. But what I can tell you so far is that the delta beam casted with the concrete has shown excellent ductility ability, and without being an expert on this field, what we were going through with our internal study is that some of the factor you will use is on the high level. But this I can showcase you in the white paper.
Okay, very nice. Actually, ductility is the main purpose to achieve it in the beam, to dissipate the earthquake force. Yes,
right.
Type. For the high shear stresses for the stud, which eliminate the drop panel or the drop slab panel. What is the difference between your stud Armata and what is available in the market, and between your different type of stud shear?
Okay, so basically, this head stud is not a new innovation. It is actually already existing in the market. The conventional method is the shearling I already mentioned, and everybody is aware of that, and how you design, how it works, and all the complicity you have at the site. So what does make our punching reinforcement different to the market player is, first of all, we are not using round bars, we are using rebar. So what you can see in this slide, if I will zoom in, these are not welded stud on the top of the rebar. It's actually one product which is heated and punched with a special machine. And then you will get the required diameter as per the ACI code. So this is the first advantage, is the rebar. So you have the yield strength is 500. And the second thing is we are able to manufacture in UAE. And as far as I know, Pico is the only manufacturer who has the production capacity or capability to do it in GCC region. As mentioned, this product is not new. The system has been existing, and what happening in the region is it is mostly imported from US or from European countries. So we are very cost effective compared to the competitor. And then of course we have free design tool, and we can give you the full design support as well.
Okay, thank you. The other question, it's I have two questions, and I will see the colleague. Actually, in your system, sometimes we notice it is mix of RC with steel, with delta beam system. With this complexity, let us say, between this different type of element structure, how we will achieve or implement the code in such kind of building?
Let me see if I understand your question. See, basically, the structural engineer will define what code to be followed.
What I mean, let's just explain this. For example, for concrete, we have the code for concrete especially. We don't have concrete for steel and concrete together. For steel, we have the code for steel. And for delta beam, you have your specification, I think, and also it is according to the codes also. But we are mixing the element, different element, concrete, steel, precast.
Actually,
so
I'm not that strong in the ACI, but what we have in the European code system, the Eurocode 4 is, if I remember correctly, is actually a code developed to address composite structure. And so the delta beam is following the guideline given in the generative code, the composite Eurocode 4. But along with that, since our delta beam is achieving the composite effect differently in what is mentioned in the generic code, we have done a lot of tests. So the delta beam has the CE marking, and this is something all the element which is produced within the European Union. So we are doing a lot of tests to verify our theoretical model with a real full-scale test to verify those.
Okay.
And so these tests are not one-time tests; these are continuous tests. As mentioned to you, the next couple of years, we are doing intense study on the ductility behavior of the beam itself. And this is again done within the European assessment, so to say. So it's in the Greece is part of the European Union. So we are following the European code, and whatever is required there, we are following that.
Okay. طيب, my question also, what I noticed from delta beam, it is value engineering.
Sorry, it's
Value engineering,
yes.
right? Because you are eliminating the drop, you are reducing the height, and all this from economic point of view.
Mm.
When we have to come to you, or when you have to come to us as contractor or the real estate development or developer?
See, the added value from PayCo is that since we have multiple application which suits for cast in situ structure and precast or combination, I will highly recommend that PayCo is involved in very early stages. And this is simply because we can guide you through. Let's say if you want to do cast in situ, okay, we have an application to meet your project target, or if the time is a constraint and the end developer is very keen on to speed up the time, then of course, based on those criteria, we will recommend you a system which will enhance those project targets. So in those cases, we will say go fully with precast. But if the time and the commercial has to go hand in hand in some kind of harmony, then we will propose you to, okay, keep the vertical element cast in situ and convert horizontal into prefab.
Okay.
So it's based on what are the project constraints, and based on those, we will advise you to go with the certain systems.
Okay.
As an example, I can give you, currently I'm working with the one consultant in Dubai, Divan, and they were doing fully cast in situ structure, one high-rise building. And Aldar, the master developer in Abu Dhabi, they were saying, no, contact PayCo, they can give you a solution for slim floor. Because they were saying, okay, let's go with precast beams, but you have a considerable drop when you go with precast beam. And they were choosing us, or the Aldar was point out to the consultant, take contact to PayCo to reach the target. So it's always a dialogue of what kind of constraint you have. Here, the developer Aldar was very keen on to rapid their construction. So for them, prefab was required, but at the same time, they want to keep a slim floor.
Okay.
So this is where we are unique and can provide you the solution.
Very, very nice. Very nice. Actually, there is a lot of a question I see, and it is related to the design issue.
Yes.
I prefer, or I will suggest for other meeting, if somebody from BICO, from design department, if he can provide other webinar, so he will focus this on the structural design, because most of the question from the colleague, it is related to structural design.
Yes, sure, definitely. I'm just going through the chat forum here, and I can see there's a lot of interest
Yes.
and the connections itself. What I can say very briefly is that yes, we are delivering beams to KSA from UAE. We have many projects ongoing in the Kingdom of Saudi Arabia, from hospital project to car parks to villa to labor accommodation. So and malls as well. So the product can be applied in various aspects, along with the shear stud as well. We have also used shear stud in different project types. And yes, we have beam software. You can model the beam in ETABS, and we will provide you the stiffness values. But I think, Engineer Abdul Hakim, I think you are very right. Let's try to do one more session, and we will take. I don't know if you are able to give us these all the question from this chat forum to us. So we will try to prepare detailing all the answers in advance, so we can go through as a presentation step by step, one by one.
Better, because most of them, they are asking in this regard. So I hope that you will be able to arrange other webinar, inshallah.
Yes, definitely we can.
Actually, we came to the end of this lecture. Thank you very much, Mr. Nick. And just I want to remind my colleague that next week we have webinar number 18 with Dr. Hassan Yusuf or Yusuf Hassan. He will talk about the new conceptual of green building. إن شاء الله بنشوفكم الأسبوع القادم زملائي الكرام وكل الشكر لكم ويعطيكم العافية. Thank you, Mr. Nirad. Thank you.
Thank you again. Thank you for giving us the opportunities, and I hope I was able to somehow fulfill the expectation of today's presentation. Thank you, guys.
Thank you. Bye bye. بدنا نعطي كم دقيقة للزملاء مشان الرابط يحطوا المهندس أنس معنا. مهندس أنس يعطيك العافية، بس عم بصير صعوبة ليحضر معنا، فلذلك يوم السبت بيكون مشغول. الله يعطيك العافية، بس عم تحضر معلش. الرابط موجود زملائنا بالشات إذا مشان التسجيل الأسماء.
We have this record.
Yes, Mr. Tahir. Record, yes, we have the record. We will publish it on our YouTube channel.
This YouTube channel address, can we have?
Yes, I will send it to you, Mr. Tahir. I will send it to you.
Thank you, Mr. Akin.
Most welcome.